In the cold, pre-dawn silence, the pilot adjusted his leather gloves, his gaze fixed on the Spitfire's propeller, a blurring silver disc that was either his shield or his coffin. A familiar dread, heavy and metallic, settled in his chest, because he knew the truth that no one spoke aloud. The engine that should protect him was just as likely to betray him, to cough and die the moment he needed it most. A half-second of silence in the deafening fury of a dive that was all the time a. Messerschmitt needed to end the fight, to end his life, and he wondered, as he had every morning for the past year, if anyone at all, could find the solution before the carburetor problem claimed him too, before the simple, brutal physics of negative G-forces bled the Royal Air Force dry of men like him. At 7:42 on the morning of March 14, 1941, Beatrice Shilling, 32 years old and with 6 dedicated years at the Royal Aircraft Establishment, stood on the tarmac at RAF Kenley, watching a Hurricane pilot climb into his cockpit for what might be his last mission, acutely aware that she still had zero solutions to the deadly problem afflicting her pilots. That week alone, the Luftwaffe had sent 43 Messerschmitt Bf-109 fighters across the Channel, and in the 27 separate dogfights the RAF pilots had engaged in, 14 Hurricanes and 9 Spitfires had gone down. The combat reports, maintenance logs, and interviews with surviving pilots all confirmed the same fatal pattern. A British pilot would spot a German fighter and push into a steep dive to attack, only to have his engine cut out as the carburetor flooded during negative G maneuvers. Simple physics with brutal consequences. The fuel would surge to the top of the float chamber, the jet would starve, and the engine would die for a crucial 1.5 seconds, just enough time for a Messerschmitt to close. 300 yards and open fire, or worse, circle back to put bullets through the stalled Hurricane while the pilot fought desperately to restart his Rolls-Royce Merlin engine. The Germans didn't have this disadvantage because their Daimler-Benz engines utilized direct fuel injection. No float chamber, no flooding, meaning Bf-109 pilots could dive, climb, roll, and invert their aircraft without losing power for a single heartbeat, granting them a decisive advantage in every engagement which the German pilots expertly exploited. And the Royal Air Force was thus bleeding experienced pilots faster than training schools could replace them. Shilling had spent 11 months wrestling with the problem, knowing that while the engineering teams at Rolls-Royce were designing a proper solution, a complete redesign of the fuel delivery system called the pressure carburetor, it wouldn't be ready until 1943, perhaps even 1944, and the war, and the pilots, could not wait. Every morning, young men climbed into their Spitfires and Hurricanes, knowing their own engines might well kill them before the Germans got the chance. Squadron Leader Davies, 24 years old with 41 combat missions and 3 confirmed kills, walked past Shilling toward his Hurricane, having reported engine failure twice in the past month, both times during combat dives, and both times having survived only by sheer luck and 3,000 hours of training. He simply nodded at Shilling, who nodded back, neither knowing that he was about to test her desperate, unauthorized solution. The carburetor problem had intensified in July 1940, when the Royal Air Force switched to 100-octane fuel, which, while providing more boost and upping the Merlin engine to 1,310 horsepower from 1,100, allowing the Spitfire Mark II to hit 370 miles per hour and catch the Messerschmitt 109s, meant the Skinner's Union carburetor simply could not handle the negative G-forces that came with high-speed combat maneuvering. Shilling, who understood carburetors better than anyone at Farnborough, had joined the Royal Aircraft Establishment in November 1939, 1 month after war was declared, becoming one of only 2 women in the engine department, the other being a secretary, and as principal technical officer in charge of carburetor research and development, she faced men who often doubted a woman belonged in engineering, but Shilling cared only about keeping pilots alive. Having grown up taking apart engines, stripping her first Norton motorcycle down to individual components at 14, and later earning the British Motorcycle Racing Club Gold Star at 25, one of only 3 women in history, racing had taught her how engines failed under stress, giving her an intuition that made her the best carburetor specialist in Britain. The solution had come to her in January, leveraging simple physics. If the flow chamber flooded because fuel flowed unrestricted when gravity reversed, what if you restricted the flow, not completely, but just enough to prevent flooding? The engine would still receive fuel, just not too much, necessitating a small brass disc with a precisely calculated hole in the center, installed in the fuel line before the carburetor to limit maximum fuel flow to slightly less than what the engine demanded at full throttle. She had machined the first restrictor herself, a brass thimble shape 0.125 inches in diameter, with a hole of 0.04 inches, testing 17 different sizes before simplifying the design into a flat washer that was easier to manufacture and install. Bench tests confirmed that the restrictor prevented flooding during simulated negative G conditions, but she desperately needed a combat test, an impossible prospect as installing unauthorized modifications on RAF fighters violated about 40 different regulations. If the restrictor failed and a pilot died, Shilling would be court-martialed, maybe even imprisoned, so she chose to skip permission, opting to ask forgiveness later. That morning at Kenley, she had 6 restrictors in her satchel and the cooperation of Sergeant William Cooper, a ground crewman who had seen 19 pilots die from engine failures in 3 years and thus didn't ask questions when she showed him the brass washer. With the pilot inside the Hurricane and the engine warming up 20 minutes before takeoff, Cooper worked fast, disconnecting the fuel line between the pump and carburetor, sliding the restrictor into place, and welding it with a small butane torch in 60 seconds of work, leaving the modification invisible unless you knew where to look. Squadron Leader Davies would fly with the restrictor, oblivious to its presence, as Shilling had told no one but Cooper, ensuring that if the restrictor failed and Davies died, there would be no paper trail, only a dead pilot and a brass washer that shouldn't have been there. The Hurricane's Merlin engine roared to full power. Davies ran through his checks, released the brakes, and rolled forward, lifting off as Shilling watched the plane climb, banking south toward the channel where German fighters had been active all week, knowing that if Davies encountered a Messerschmitt, he would have to dive, and the restrictor would either work or it wouldn't. She waited on the tarmac for 40 minutes, then an hour, calculating fuel flow rates in her head. The math worked, but math wasn't combat. At 9:37, the radio crackled with the controller's voice. 3 Hurricanes inbound, 2 minutes out. Raising her binoculars, Shilling saw them, 3 dark shapes against the morning sky, all 3 aircraft safely returning. Davies landed first, taxied to dispersal, cut the engine, and climbed out, smiling, an unusual sight, as pilots rarely smiled after combat patrols. Cooper immediately asked, "Any problems with the engine, sir?" Davies looked at Cooper, then at Shilling, and back at Cooper, responding, "Best the Merlin's ever run. Dove on 2 messes over Dungeness. Engine never missed a beat," explaining that he had spotted 2 109s, pushed into a steep dive at 400 miles per hour, a dive that should have killed his engine, but the Merlin kept running at full power, allowing him to close to 200 yards before the German pilot saw him. He fired a 3-second burst, saw strikes on the Messerschmitt's wing route, and watched the German fighter brake hard right and flee toward France, the engine having performed flawlessly. It was the first time in 11 months that Davies had successfully pressed a diving attack without his engine cutting out, and when Shilling explained the restrictor, the brass washer, and the fuel flow limitation, Davies stared for 5 seconds before turning to Cooper and saying, "Put that thing in every Hurricane on this station. Today." Davies didn't care about authorization, he cared about surviving combat, and with every pilot at Kenley having lost friends to engine failures, he declared that if the brass wanted to court-martial him for installing an unauthorized modification, they could do it after the war, but right now his squadron needed working engines. Cooper installed restrictors in 4 more Hurricanes that afternoon, and over the next 3 days, 5 Hurricanes flew combat patrols with restrictors, reporting 0 engine failures and successfully pressing 12 diving attacks against German fighters, with some pilots even claiming they were getting more power at altitude. Word spread fast, and by March 18th, every squadron commander in 11 Group knew about the restrictor, demanding it immediately. But the problem was supply. Shilling had machined only 6 restrictors herself, and manufacturing thousands required proper production facilities, brass stock, and precision equipment. She needed Air Ministry approval and funding, and she got it in 4 days. The Air Ministry fast-tracked her proposal, calling it a war-winning modification, and Rolls-Royce received the production contract to manufacture 500 restrictors per week, with installation beginning immediately at every fighter station in Britain. Shilling assembled a small team and began touring RAF stations to oversee the installations, which could be fitted without removing the aircraft from service, a critical factor for RAF Fighter Command, which couldn't afford to ground its Spitfires and Hurricanes as German fighters still crossed the Channel daily. By March 25th, 600 restrictors had been manufactured, 40 stations were on the schedule, and 3,000 Merlin engines waited for modification. Shilling started her Norton motorcycle and headed north toward Biggin Hill, the busiest fighter station in 11 Group, where Group Captain Grace, who had lost 7 pilots to engine failures in the past 2 months, met her at the gate and demanded immediate installation. The ground crews worked in shifts, taking 12 minutes per aircraft, with Shilling supervising every installation personally, checking every weld, testing every connection, and rejecting 3 restrictors that didn't meet specifications. Pilots watched with intense interest. Flight Lieutenant James Lacey, an engineering graduate from Cambridge who had experienced engine failure twice in 41 combat missions, called the simple washer brilliant simplicity. By March 28th, all 53 Merlin engines at Biggin Hill had restrictors installed, and Shilling moved on to Hornchurch, North Weald, and Tangmere, the pattern repeating at every station. Ground crews worked 12-hour shifts, pilots flew combat patrols with modified engines, and 0 failures were reported, the restrictor working exactly as designed. Pilots started calling it Miss Shilling's orifice, a nickname coined by Sir Stanley Hooker, chief engineer at Rolls-Royce, which, though crude, Shilling accepted, knowing that if crude humour helped them remember the modification, she would accept any name they chose. The nickname spread faster than the restrictor itself, and by April, every pilot in Fighter Command knew about it, with some refusing to fly combat missions until their aircraft had the modification installed. German intelligence noticed the change in British fighter performance, with Luftwaffe after-action reports mentioning improved RAF diving attacks and noting that Messerschmitt pilots could no longer exploit the carburetor weakness. The tactical advantage had disappeared. By mid-April, Shilling's team had installed restrictors in 2,100 Merlin engines, every Hurricane and Spitfire in Fighter Command, every operational training unit, and every aircraft in reserve status, and the modification became standard equipment, with new aircraft rolling off production lines with restrictors pre-installed. Though the pressure carburetor was still in development, the restrictor worked so well that some engineers questioned its necessity. Shilling knew the restrictor was merely a brilliant, temporary stopgap, but until 1943, Miss Shilling's orifice kept RAF pilots alive, and that was enough. The combat statistics meticulously tracked by Fighter Command told a clear story. In March 1941, before the restrictor, RAF fighters reported engine failures in 38% of diving attacks, often causing them to break off pursuit or be exploited by German pilots. In April 1941, after the restrictor, engine failures during diving attacks dropped to a near non-existent 0.4%, with the kill-to-loss ratio improving immediately from 1.3 to 1 to 3.2 to 1. And while the restrictor wasn't the sole factor, squadron commanders credited it as a major contributor. Pilots reported increased confidence in combat, with Flight Lieutenant Robert Stanford Tuck, who had experienced engine failure 4 times before the modification, destroying 5 Messerschmitt 109s in May and June after installation, crediting the restrictor with giving him the confidence to commit to aggressive tactics. The modification spread beyond Fighter Command, with RAF Coastal Command requesting restrictors for their Beaufighters, Bomber Command for their training aircraft, and even the Fleet Air Arm inquiring about installation on carrier-based fighters, leading Shilling to coordinate production with Rolls-Royce, which was soon manufacturing 1,000 restrictors per week. The restrictor remained in service through 1943, even after Rolls-Royce finally introduced the pressure carburetor in January 1943, which eliminated the negative G problem completely, as converting existing aircraft required 8 hours of maintenance, an extensive modification that Fighter Command could not afford to execute across their entire fleet while still flying combat missions. Thus, many older aircraft kept their restrictors until 1944, some until the end of the war, because pilots trusted them and ground crews knew how to maintain them. If it worked, don't change it. Shilling moved on to other projects, working on cold weather starting systems for engines in Iceland and Russia, researching high-altitude fuel mixture problems, and helping to design improved supercharger systems for late-war Merlin variants. She had joined the Royal Aircraft Establishment to solve critical problems that threatened pilot lives, and her work continued. She developed a cold start procedure for Spitfires deployed to Murmansk, where Russian winter temperatures dropped to -40 degrees Fahrenheit, allowing the aircraft to fly combat missions through the winter of 1941. And she developed altitude-compensating carburetor modifications that improved the Merlin engine's power output by 8% above 30,000 feet. Her personal life, including her marriage to George Naylor, who flew Avro Lancasters with 625 Squadron for RAF Bomber Command and earned the Distinguished Flying Cross, remained separate from her work, and though she worried about him every time he flew, he survived his tours and returned to Farnborough in 1944. Shilling continued racing her Norton motorcycle when time permitted, finding that fast riding helped her think and solve problems that laboratory work couldn't crack. By 1945, she had worked on 17 major projects at Farnborough, each one saving lives and keeping RAF aircraft operational under extreme conditions, but none achieved the fame of the restrictor. The war ended in May 1945, and Shilling stayed at Farnborough as the Royal Aircraft Establishment transitioned to peacetime research. In 1948, she received official recognition for her wartime contributions when King George VI appointed her Officer of the Order of the British Empire, a ceremony at Buckingham Palace after which she immediately went back to work. Shilling continued her engineering career for another 21 years, until 1969, working on projects like the Blue Streak missile program and researching wet runway braking effects for jet aircraft, publishing 3 technical papers on the subject, and even helping to design a bobsled for the RAF Olympic team, though she never reached the top administrative positions, which were reserved for men. She preferred hands-on engineering work anyway. She retired in 1969 at age 60, spending her retirement restoring vintage motorcycles, racing occasionally, and maintaining the same Norton she'd owned since 1934, the machine that had taught her how engines behaved under extreme stress. She died on November 18, 1990, at age 81, but her legacy lived on. Keith Maddock, chief engineer at Hangar 42 during the war, later stated, "Beatrice Shilling helped us win World War II. Of that, there is no doubt, and her invention became a teaching example in engineering schools worldwide. The simple solution to a complex problem, immediately implemented under wartime pressure, with measurable, life-saving results, the brass washer that saved the Royal Air Force."